What's going on, everyone? How are you? Hope you're well. Wanted to go over angle measure and angles when you have parallel lines, like line M and N are parallel, cut by this transversal right here. So line P is a transversal, it means it goes across the two parallel lines. Okay, when that happens, it creates these 8 angles. And some objectives. Basically, we're going to try to look at parallel lines cut by a transversal theorem. Okay, there's some properties that happen. And its converse we'll learn a little bit more about in integrated 2. We're going to learn how to find angle measures using that theorem up above. We're going to use algebra to find an unknown variable and to find angle measures when you have parallel lines and transversals. And then we're going to use auxiliary lines, which means those dotted lines are lines that you draw that aren't on the original drawing. Okay, so let's just go through a few things. So M and N are parallel lines. These two marks indicate that they're parallel. Those are called chevrons, and line P is a transversal. In between the two parallel lines, that's the interior, and then outside of the two parallel lines, considered the exterior. And then these angles, 1, 4, 5, and 8, okay, those are on the same side. And then 2, 3, 6, and 7 are on the same side. And then 1 and 6, or 1 and 7, or 4 and 6, they're on alternate sides, okay, or opposite sides. You can't say opposite, and I'll explain that in a second. But when two parallel lines are cut by a transversal, the following pairs of angles are congruent. Okay? And congruent means exactly the same. So the first one that you have, I'm going to indicate here, are the corresponding angles. So corresponding angles mean that if I were to take this group of 4 angles, pick up this point, this vertex, and lay it down on top of these 4 angles, the ones that match up are the corresponding angles. So an example of the corresponding angles would be angle 4 and angle 8. Those are corresponding angles. So angle 4 and 8, okay, are corresponding. Let's move up a little bit. 1 and, what do you guys think? 1 and 5. Okay. On the opposite side, you got 2 and 6, and 3 and 7. Those are corresponding angles. Okay, alternate interior. Remember, alternate means on the other side, okay? Interior means they are on the inside of the two parallel lines. So, in this case, an example of alternate interior angles would be angle 5 and angle 3. So it kind of makes this Z formation right here. The alternate interiors. And like I said, 3 and 5 are alternate interior. And then 4 and 6 would be alternate interior. And then lastly, in this section, you've got alternate exterior. So using a little bit of logic here, if I took angle 1, what would be on the alternate side of angle 1 that's on the exterior of the angle? That would be angle 7. Okay, so alternate exterior, 1 and 7, and then 2 and 8. So all of these are congruent, which means they all have the same measure. So if angle 1, let's say, is 100 degrees, well, then angle 7 is 100 degrees. And the reason is those are alternate exterior angles. 1 is 100, 5 is 100, because they are corresponding angles. So we'll get more into that in just a little bit. All right. The other part of this, supplementary, if you remember from last week, supplementary angles are angles that add to 180 degrees. Consecutive interior often is called same side interior. So, example, angle 4 and angle 5. So, same side interior, consecutive interior would be 4 and 5 and 3 and 6. Okay, and then remember, there are a couple other situations that I can explain using this diagram down below that we've already learned in the class, but it's helpful to just kind of be reminded of them. Remember, 1 and 3 are opposite of each other. Those are called vertical angles. Okay, so vertical angles are 1 and 3, 2 and 4, 5 and 7, and 6 and 8. Okay, and vertical angles are also congruent. That means congruent. All right, so vertical angles there, so on and so forth. Okay, 8 and 6, they are identical. The last thing that I kind of wanted to touch on that's related to this is what we called earlier this year linear pair. And a linear pair, they add to 180 degrees, and they are angles like 1 and 2, 1 and 4, 2 and 3, 4 and 3, because when you put them together, like if I add this angle to this angle, and they share the same vertex, that's really important, it makes a half circle or 180 degrees. So that angle measure makes this line that goes across, line M. Okay, and you can break it up horizontally, or 1 and 4, you could draw another one this way, and it would create line P. So 5 and 6 are a linear pair, 6 and 7 are a linear pair, 7 and 8 are a linear pair, and 5 and 8 are a linear pair. But 5, let's say 5 and 2, those two add up to 180 degrees, but they're not a linear pair because they don't share the same vertex. Okay, so just a quick recap, you guys. Got corresponding angles, they're matching. Alternate interior, they're on the inside on the opposite side of the transversal, so like 3 and 5 and 4 and 6. Alternate exterior, they're on the outside and they're on the alternate side or the opposite side. Okay, consecutive interior angles, remember they add to 180 degrees, so they are said to be supplementary. All right, that's like 4 and 5 and 3 and 6. Vertical angles are congruent, they point at each other, or they're opposite angles often called, and they're congruent. And then a linear pair are two angles that add to 180 degrees that share the same vertex and form a line. They share the vertex and they share a side of the angle, like 1 and 2.